722, and just much like what we've been doing, so we'll try to get through this one a little bit quickly. But 21 is, WNAE is new station. Anyhow, the mean of listening time is 15 minutes, the standard deviation 3.5 minutes, so we put that in there. So we want to know what's the chance that somebody would tune in for more than 20 minutes, right? So again, if we do our math, and I haven't really done a good job of that here, I'm going to come out here, and it's just equal to, right, our n in this case is 20. So 20 minus our mean, okay, divided by our standard deviation. 1.43 basically, and so I looked that up in my chart. Right, 1.4 and 3, so I'd come up with 0.4236, but it's saying I want to know what's the odds that it would be more than that, right? Okay, and so I would, what I say, 0.4236, and it's to the right though. Okay, and so let's calculate everything that's to the left of that by adding 0.5. And so I got that equal to or 0.9236, very similar to what I have over here. Okay, but I have to, again, I want to look at everything that's to the right of that, and so if I go look at my little deal, and I want to start here, what was I, 1.14 or something? Can't remember.
Here, let me shut that door.
About 1.43 if I'm not mistaken, so 92.36. But what's the inverse of that then? Okay, I want to look at the stuff that's to the right of that. Okay, so it's just going to be 1 minus, right? Everything goes up to 1 because it's all in percentages, so everything goes up to 1. So it's going to be 1 minus that 0.92. I did the distribution, so it's very much the same, and it shows those, I guess, on page 225. But this just equal then to 1 minus that. Okay, and I can sure put that in a percentage too. Okay, and I should have just done B first because 20 minutes or less, right? That's just the number that we came up with, so I won't spend a lot of time doing that. And then between 10 minutes and 20 minutes, and this one gets a little bit complicated because we're going to be dealing with, negative values, right? Negative values, and we want to figure out what it is between those. And, that's a fairly small range there, I would say. Okay, and so, again, we should do our math probably. And do well, let's show you the normal distribution because that's kind of what I've done here. Okay, so I'll delete it and we'll do the normal distribution. Okay, most recently used normal distribution. Again, my x in this case for my first one is 10, my mean is 15, my standard deviation is 3.5, and I'm going to use the 1. Okay, so again, this is this is cumulative from the far left of that normal distribution, right? So it's 7.66%, right, from the far left there. Okay, and that's for equal to 12. All right, I can say equal to 12. I need to find out my number then that's equal to 15. I'm sorry, it's not 15, it's it's 10 and 12. Golly, isn't that terrible? So this one's equal to 10, and this one's equal to 12. Sorry about that. Okay, make sure I put that in there right. I did. So now let's take a look at 12. Okay, so we'll hit the delete and start all over. Normal distribution, it's going to be the same, right? It's going to be a bigger number. Know that ahead of time, right? Okay, so my x is 12 in this case. My mean is 15. My standard deviation is 3.5. Cumulative, hit true. Okay, so 19.57. But again, I want to know what it is between those. Okay, I want to know what it is between those, and so simply I say it's equal to this one minus this one. I get 11.91% or 0.1191. Okay, here's I did it, the old-fashioned way. Got my numbers. These are the numbers when I look them up in the table, and I'd come up with 0.1185. Okay, either answer would be correct and acceptable.